Roaming is a common but particularly troublesome issue in wireless networks. Common problems in roaming include sticky clients or a delay in roaming that leads to network packet loss and bad user experiences. We know that roaming experience is related to AP deployment and the roaming settings of terminal devices. On the one hand, different locations have their own characteristics. Some locations are more dense in AP deployments, some are less. Meanwhile, obstacles also affect roaming experiences. Some areas have corners, some areas are small and limited while some are broader. These different locations mean that even for the same terminal, the roaming strategy will vary. On the other hand, different terminals have their unique roaming strategies. Some terminals may be more sensitive to the signal, while others are not. Therefore, if we use the same roaming strategy for all APs, it can be challenging to adapt to different characteristics of various terminals. Given the two aspects mentioned above, if we want to manually adjust the roaming strategy based on different clients and AP deployments, it can be time-consuming, and we cannot make sure that the roaming strategy fits every client and provides the best roaming experiences. If there are many APs in a project, it is almost impossible to adjust the roaming strategy of different terminals one by one. So, in such cases, we use reinforcement learning algorithms to generate personalized roaming strategies. Reinforcement learning is a machine learning algorithm. Through the interaction with the environment, AI continuously makes adjustments and receives feedback to learn what is the best roaming strategy that matches the environment. AI adjusts the roaming strategy at different locations like a human being and constantly observes whether there is an improvement in the roaming experience at different places. If there is an improvement, it continues to adjust. If it finds that the experience hasn't improved or has even worsened, it goes back to the previous state. This process will repeat several times to improve roaming experiences, which is what we commonly refer to as the more you use it, the better it gets. If we compare terminal devices to race cars in a racing game, then our wireless environment is like a complex racetrack. The segments between access points are similar to different sections of a racetrack. In a racetrack, different sections require different actions. Some segments require acceleration, some require deceleration. Our AI acts like a smart race car driver who can control various cars with different performances. It adopts different strategies according to the performance of different race cars and racetracks to enable the race car to reach the destination safely and fastly